Use Newton's method to estimate the solutions of the equation f of x is equal to x squared plus x minus 1. We want to start with x naught equals negative 1 for the left-hand side solution, and we want to start with x naught is equal to 1 for the right-hand side solution. And we're asked here to find x sub 2 in each case. So, to get us started here, let's think about what we're given. So we have our beautiful function being defined as the quadratic f of x is equal to x squared plus x minus 1. And using this, we can find the derivative f prime of x, which is 2x plus 1. So we'll start with our left-hand side solution. So for our left-hand side, which we have labeled up here on our graph, we are going to let x naught equal negative 1. So part 1, we need to use this to find x sub 1. And using Newton's method, the generalized form up here, we know that x sub 1 will be equal to x naught minus f of x naught all over f prime of x naught. So in this specific case, this is going to be negative 1 minus f of negative 1 all over f prime of negative 1. So let's start by finding the individual pieces here. So let's see, we have f of x naught, or f of negative 1. And plugging this into our function, we have minus 1 squared plus a negative 1 minus 1. So this is positive 1 minus 1 minus 1, which leaves us with negative 1. We now want to evaluate the derivative at x naught, or f prime of minus 1. This is 2 times negative 1 plus 1, and minus 2 plus 1 gives us negative 1. So therefore, x sub 1 is minus 1 minus f of negative 1 divided by f prime of negative 1. So I have minus 1 minus, we have negative 1 in the numerator divided by negative 1 in the denominator. So lots of negatives here. Be careful with your algebra. We've got negative divided by negative, which will become positive. So I have minus 1 is negative 2. And we have officially found x sub 1. So x sub 1 is negative 2. So now we need to use this to find x sub 2. And again, we're going to reference Newton's generalized form, or formula. So x sub 2 is x sub 1 minus f of x sub 1 divided by f prime of x sub 1. And in this case, this is going to be negative 2 minus f of negative 2, all divided by f prime of negative 2. So again, I'm going to start by finding the individual pieces. Evaluating our function at negative 2, this is minus 2 squared plus negative 2 minus 1. So we have 4 minus 2 minus 1, which gives us 1. And then f prime negative 2 will be 2 multiplied by negative 2 plus 1. So minus 4 plus 1 equals negative 3. So we have x sub 2 being equal to minus 2 minus the function evaluated at negative 2, all divided by f prime of negative 2. So minus 2 minus 1 divided by negative 3. So again, negative divided by negative leaves us with plus. So we have negative 2 plus 1/3. So when I get that common denominator here, so I can think about negative 2 as minus 2 by 1, multiplying the numerator and denominator by 3. we have negative 6 thirds plus 1/3 for a beautiful final answer of minus 5 thirds. So therefore, the second approximation for the left-hand side solution is minus 5 thirds. And this is our beautiful answer. So now we want to go ahead and do the same thing for the right-hand side solution. So example continued, we want to estimate x sub 2 now for the right-hand side solution. And we are using the same given function and the same derivative that we found for the left-hand side. And this time we are starting with x naught equals 1. So the first thing we need to do is find x sub 1. And again, we want to reference Newton's generalized method. So this tells us that x sub 1 is going to be equal to x naught minus f of x naught, all divided by f prime of x naught. So here our x naught is 1. So this will be 1 minus f of 1, all divided by f prime of 1. And we're ready to go. So we want to find these individual evaluations and then substitute them in. Excuse me. So we have f of 1. So this will be 1 squared plus 1 minus 1 for a beautiful final answer of 1. We have f prime of 1, which will be 2 times 1 plus 1, which leaves us with 2 plus 1, or 3. So therefore, x sub 1, again, will be 1 minus f of 1 divided by f prime of 1. Plugging everything in, we have 1 minus 1/3. And getting that common denominator again, we can think about 1 as being 1 by 1. Multiplying the numerator and denominator by 3, we end up with 3 minus 1 over 3, which gives us 2/3. So x sub 1 in this case is 2/3. And we can now use this to find x sub 2. And again, starting with Newton's generalized method, we know that x sub 2 is defined as x sub 1 minus f of x sub 1 all over f prime of x sub 1. So this will be 2/3 minus the function evaluated at 2/3 all over f prime of 2/3. And we're ready to go. So we have f of 2/3. Plugging this into the original function, we have 2/3 squared plus 2/3 minus 1. So this will be 4/9 plus 2/3, and I'll rewrite minus 1 as minus 3/3. So this simplifies to 4/9 minus 1/3, and getting a common denominator here, multiplying the top and bottom of 1/3 by 3, we're left with 4 minus 3 over 9 for 1/9. And we want to do the same thing now for the derivative. F prime of 2/3 will be 2 multiplied by 2/3 plus 1. So we have 4/3 plus 1, or we can even think about 1 as 3 over 3, which gives us 7/3. And last but not least, we can find x sub 2, which again will be here 2/3 minus f of 2/3 divided by f prime of 2/3. And plugging in what we just found, we have 2/3 minus 1/9 divided by 7/3. And so we know fractions in the denominator like this can be flipped, or we multiply by the reciprocal. So I have 2/3 minus 1/9 multiplied by the reciprocal of the denominator, 3/7, which can be simplified. We know 3 goes into 9 3 times. So I have 2/3 minus 1 over 3 times 7 gives us 21. So we need a common denominator here. We'll multiply 2/3 by 7 over 7, which leaves us with 14 minus 1 over 21. which simplifies to 13/21. So therefore, the second approximation for the right-hand side solution is the beautiful final answer, 13/21.